Hello everyone, it's Wilson here. We have a geometric series here, and we want to determine whether this geometric series is convergent or divergent. And if it's convergent, we want to find the sum because it has a finite sum, right, when it's convergent. So how do we do that? If we just look at the expression right here, it doesn't really look like a regular geometric series because it's not in the standard form that we usually see from a geometric series. So the first thing that we can do for this series is to just rewrite the expression so that we can turn it into a standard form or a form that is easier for us to see the common ratio so that we can determine whether it's convergent or divergent. Okay, so let's get started. First, we look at this series right here. We look at this expression right here. We can claim that's a sub n, right? So we have phi to the n plus 2, and then divided by 2 to the 3n minus 2. Okay, so now let's start breaking things up. So we have 5 to the n times 5 to the second power. Okay, we are just using the rules of exponents. And then in the denominator, we are going to get 2 to the 3n, right? Yes. And then times 2 to the minus 2. Okay, so let's continue. We have 5 to the n times this 5 squared is 25, right? So we just get the 25 here. And continuing from there, if you look at this one, there was 2 to the third and then raised to the n power. So we can actually write that as a to the n times. Now this is 2 to the negative 2. See that the exponent is negative, so we are going to get a fraction here because we are going to take the reciprocal of the 2, which will give us 1 over 2 squared. So that's giving us 1 over 4. Okay, so let's just keep simplifying this. We are going to get what? The 25 in the numerator times the reciprocal of this 1 over 4, which is just multiplying by 4. So we are going to get 100. And then what about the 5 to the n and 8 to the n? We can actually put them together because they have the same exponent. So we are going to be getting 5 over 8 to the n power. So now we actually have just rewritten this expression into this form here. And remember that n is starting from 1. So to get the first term, we actually need to plug the 1 into the n, and then we can get the first term, right? But let's don't worry about that right now. We want to determine whether the series is convergent or divergent. Okay, so we have a series test here by the geometric series test, right? Geometric series test. Okay, what does the test say? What it says is that if you take the absolute value of the common ratio r, and in this case it's 5 over 8, and that's equal to just 5 over 8 when you take the absolute value of a positive number. It's the same number, and that's less than 1, right? So because it's less than 1, then we can actually say that the series is convergent. The series is convergent. Okay, so let's just highlight these things right here so that you know that, okay, so that's one thing that's important. And then the other thing is that the conclusion is also important, right? Okay, so far so good. And then now, because the series is convergent, then we can find the sum. To find the sum, we actually need the first term. We also need the common ratio. We already have the common ratio here, which is 5 over 8. We want the first term. How do we get the first term? And as I said before, we are going to plug in the 1 into the n here, and then we can get the first term. So what do we get here? We have a sub 1, right? Actually, I should just change it to a different color. So a sub 1 is going to be what? It's going to be 100. So see that we are actually taking this expression, and then we're going to get 100 times 5 over 8 to the first. And then, of course, 5 over 8 to the first is really just 5 over 8. So we get 100 times 5 over 8. Then we can do some cancellation right here. We can divide top and bottom by 4, right? We're going to get 2 here. And then divide the 100 by 4, we're going to get the 25. So the answer would be 125 and then divided by 2. So now we can actually find the sum. So the sum is going to be what? Sum is going to be a sub 1. Okay, that's the first term divided by 1 minus r. And so what is a sub 1? It's going to be 125 divided by 2. And then what do we get in the denominator? We are going to get 1 minus r. What is r here? R is actually 5 over 8. So we put that here. Okay, so this looks like a messy expression, but it's actually not too bad. So we have what? We have 125 divided by 2. And then divided by, what do we get here? We have 1 minus 5 over 8 in the denominator. So we're going to get 3 over 8. Okay, so we can rewrite the division into multiplication. We have 125 divided by 2, and then times. Now we got to take the reciprocal of this 3 over 8, which is a over 3. And so what do we get here now? Let's do the canceling here. We have the 2 canceling with the 8, so we get the 4 at the top. So now we have the sum, which is what? Which is 125 times 4 at the top, which is 500. And then in the denominator, we just have 1 times 3, which is the 3, so we're finished. So that's what the sum is. It's 500 over 3. There is one thing that I want to point out here is that really oftentimes we can, sometimes people will just say that, okay, so 100 is the first term, but that's not the case here because when n is starting from 1, if you want to claim that this would be the first term, we actually need to have n minus 1 right here. But because we do not have n minus 1 here, we cannot claim that 100 is the first term. So when do we say that 100 is the first term? That's when you're starting with n is equal to 0. Then this is actually that so that the series will be in the standard form. And then in that case, we can claim that 100 is the first term. But of course, that's not true for our series here because n is starting from 1. Okay, so in this case, we actually need to do extra calculation like this extra step right here. We need to plug in the starting value for the n into our a sub n, and then we can do the calculation, and that will be our first term. Okay, so that's our final answer here. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you.